Hello dear children, how are you all? Hope you all are fine and doing well. Dear children, we are doing the motion chapter. In a previous class, we could cover half of the chapter. In today's class, just look at the agenda, what are we going to cover? In today's class, we are going to cover speed, types of speed. Especially, we discuss uniform motion, that is the uniform speed and a non-uniform speed, average speed, and we discuss even mass and weight. So dear children, these are the topics which we are going to cover in today's class. Let us recall once again whatever we could discuss in a previous video. Dear children, in a previous video we discussed about what is rest and what is motion. Children, let us recall once again. When you can say that a body is at rest. So if your body is not changing its position with respect to the surroundings, then we can say that that body is at rest. Whereas, if any object is changing its position with respect to the surroundings, we can say that that particular body is in motion. Means here, rest and motion both are relative terms. Means, same object at the same time can be at rest, can be in motion. It depends on the observer. I repeat once. So, it depends on the observer only. A body, we can decide either body at rest or body in motion. Next, we discuss about what is a translational motion. Dear children, what is translational motion? So, if a body is in motion such that each and every particle of that particular body is covering the same distance in a given time, then we can say that that body has a translational motion. And a translational motion is of two types, right? One is rectilinear motion, second is a curvilinear motion. What is a rectilinear motion? If any object is going along a straight line path, such a motion is rectilinear motion or linear motion. Then what is a curvilinear motion? If any object is going along a curved path, then we can say that that body is in curvilinear motion. Is the point clear? Fine. Next, we covered about the rotational motion. So in a rotational motion, body has a motion about a fixed axis. Whereas when you just take over the what we call circular motion, in a circular motion, body will go in a circular path. But what is the main difference between these two, dear children? Yes, in a rotational motion, the axis of rotation will pass through the body. Whereas in the case of circular motion, the axis of revolution will pass through the point of the circular path. Point of the circular path means that axis of revolution won't pass through the body. Fine. Yes. Next, oscillatory motion versus vibratory motion. Both seems to be same. What is the oscillatory motion? The to and fro motion of an object about a mean position is called oscillatory motion. What about the vibratory motion? Almost it is also to and fro motion only. But difference is that in a vibrational motion case, some part of the body is fixed, and in this vibrational motion, body shape and size will be changed. So that makes a difference. Okay, fine. Next, periodic motion, non-periodic motion. What is the periodic motion, dear children? If a motion of the particular body is repeated in a regular interval of time, then we can say that motion is a periodic. If the motion is not repeated in a regular interval of time, then we can say that it is a non-periodic motion. Is the point clear? So these are the actually we covered, and next we discuss about the mixed motions, dear children. In a mixed motions, body can have more than one motion. For example, if you can see the ceiling fan, not a ceiling fan, of course, ceiling fan only will have a rotational motion. Take the case of the earth. Earth will have a rotational motion. At the same time, it will be in a circular motion also. And one more important, if you can observe the table fan, dear children. So the wings of the table fan will be rotating. Okay, means rotational motion, but at the same time, it will have oscillatory motion. It will have oscillatory motion. In that case, okay, means you are keeping a swing, at the same time it is in on mode only. Then we can say that in that case it has a rotational motion and as well as oscillatory motion. Okay, fine. And in today's class, as I told you that we will be talking about the speed. Dear children, this is not a new word to all of us. We are very familiar with this term, right? Many of us, we can say that, hey, increase the fan speed, decrease the fan speed. We can use in our day-to-day life. And if we can observe the vehicles which are going on the on road, Is it clear? For example, all are going in a proper way. If any person is overtaking, then we can say, see that fellow is going very fast. Okay na? Or else, for example, you are in a vehicle. Okay na? You are getting late for your office or a school or somewhere. What will tell to your driver? You can say that, uncle, please, why our vehicle is going very slow? Just make it more fast. So this is very important. So we can use two words in our day-to-day: fast and slow. So speed is a physical quantity which will tell how fast or how slow an object is moving. I repeat, very, very, very important. So here, speed tells about how fast or how slow an object is moving. An object or a body or what we can say vehicle is moving. Very important. In simple terms, students, simple terms, speed tells how fast or how slow an object is moving. Then how can we calculate the speed of an object? How can we define what are the units and how can we do the conversions between the units of the speed? So these are very important for examination point of view. You don't worry, dear children. Hope you all are ready with your pen and notebook. Try to take the notes, very important. Note down the notes, very important. And whenever you will get any doubt, pause the video, comment, what we can say, express, what we can say, mention your doubt in a comment box. Definitely, I'll get back to you with a solution. Okay, fine children. So let me take one example. For example, here, it is the point A, it is the point B, it is the point C, here is some point D. So here A to B, let us say it's a 10 meters. B to C, it is some, for example, 5 meters. C to D, it is a 15 meters. Just what we get formality, I am taking this example to make to give you a clarity. For suppose here a person is standing at point A, let us say that. Okay, now. So he is going from point A to B. As he is going from point A to B means, yes, he is in motion. He is in motion. But if you consider children, let us say to go from point A to B, he is taking 2 seconds of time. Oh, okay. 10 meters in 2 seconds. My God, world record. Okay. Okay. Whereas from what we can say point B to C, to go to point B to C, let us say he is taking a 5 seconds time. 5 seconds time. She'll try to understand. So to go to A to B, that is a 10 meters distance. To cover the 10 meter distance, same person, what let us say, okay, he is a person X, person Y, let us say that. Two different cases. Okay. Now. So this person X to go from point A to point B, that is to cover 10 meters distance, taking 2 seconds. Whereas person Y to go from point B to point C, which is at a distance of 5 meters, taking 5 seconds. Now according to you, dear children, who is going faster? Who is going slower? Come on, children, pause the video and comment your answer. Now, I repeat once, person A is covering 10 meters in 2 seconds. Person X, person Y is covering 5 meters in 5 seconds. Who is going fast? Who is going slow? Then, of course, some of you may guess, but actually, mathematically, how to prove who is a faster, who is a slower? So, as I told you that is what we can say a duty of the speed, right? Speed will tell how fast or how slow an object is moving. Who is going fast? Who is going slow? Who will tell you, ma? Speed will tell you. Then you will get to know, sir, then how to calculate the speed? Yes, dear children. So, simple formula we have. Speed is equal to, please note down, speed is equal to distance covered by time taken. Simple as that. Now, for a person X, children, for a person X, speed I want to calculate. So, see, generally we use the letter V to represent the speed. Okay. Now, speed of person X is equal to, distance covered is how much? 10 meters by time is 2 seconds. So, it will be 10 by 2 is how much? 5 and meter per second only. Simple. Okay. Now, what is the speed of the Y, dear children? Look at here. Distance covered is how much? 5 meters. Okay. Time taken is 5 seconds. 5 by 5 is 1. So, this is a 1 meter per second. Now, what can we conclude? Yes, we can conclude that speed of person X is greater than speed of person Y. That's it. So, to calculate the speed, dear children, which formula are we going to use? Very simple formula which we are going to use. What is that here? distance covered by time taken. Distance covered by time taken. Am I clear? Fine. Now, let us see the units of speed, dear children. Units of speed. In SI system, dear children, distance is measured in meters, okay, and time is measured in second. Hence, meter per second is a unit, SI unit of speed. Whereas, what is a CGS unit? In a CGS system, distance is measured in centimeter, time is measured in seconds. The children, if you want to know the units of speed, just substitute the units of distance and time. That's it. You will get the units of speed. Okay. So, it will be centimeter per second. Fine. And now day-to-day life, dear children, whenever the vehicles are going, we can talk that the particular speed of the vehicle is some 80 km per hour, 60 km per hour. Which means what? We will use kilometer per hour even to measure the speed of the vehicle. So, we have one more unit, special unit, kilometer per hour. Sorry, not second, kilometer per hour. But examination point of view, how kilometer per hour is related to the meters per second is very important. So, in exam, they will give you conversions. They will give you speed in meter per second. They will ask you to convert into kilometer per hour. Or in speed is given in kilometer per hour, it is asked to calculate the meter per second. If you want to do such a kind of conversions, we must know the relation between meter per second and kilometer per hour. Shall we do it? Are you ready? Chalo dear children. So before that, look at here. We should have this knowledge. What is that? 1 kilometer is equal to how many meters, dear children? 1 kilometer is equal to how many meters? Come on, think. Yes, it is 1000 meters. Very good. I think you are telling there. I can understand. Okay. Then 1 hour is equal to 60 minutes. I know that. But how many seconds? 60 minutes. Right on this. 1 hour is equal to 60 minutes. But here 1 minute is equal to again 60 seconds. So 60 into 60, that is 3600 seconds. Okay, fine. So 1 kilometer per hour. Dear children, in the place of 1 kilometer, we can write 1000 meters. Okay, fine. Whereas in the place of 1 hour, I can write 3600 seconds. 0, 0, 0, 0. 2 5s are 2 18s are. So 1 kilometer per hour is equal to 5 by 18 meter per second. Children, this is very, very, very important. Are you able to see this? Let me check. If not, okay, exactly. Okay. So 1 kilometer per hour is equal to 5 by 18 meter per second. Okay. Then 1 meter per second is equal to, bring this 5 by 18 this side. So it will become reciprocal. Okay. So here 1 meter per second is equal to 18 by 5. Very good. 18 by 5 kilometer per hour. Very, very, very simple. Okay. Got it? Now we do one thing. A simple 1 or 2 examples we will take so that you will get a full clarity regarding the conversions of a speed. Okay, children, are you ready? Okay, hope you have copied. Shall I erase this? 1, 2, 3. Go. Yes, very fast I'll do it. Yes, look at it. Example 1. So, speed is equal to, is given, what you can say, 36 kilometer per hour. We have to express, they will ask you, express the speed in a meter per second. How to do it? Look at here. Children, 36. So, if you want to convert kilometer per hour to meter per second, use this expression. In the place of 1 kilometer per hour, you must substitute this 5 by 18. So, it is 5 by 18 meter per second. 18 ones are 18 twos are. So, this will be 10 meter per second. So, 36 kilometer per hour is equal to 10 meter per second. Very simple. Now, second example. For example, speed of a vehicle. Speed of a vehicle is given, for example, 100 meter per second. 100 meter per second. We must convert into kilometer per hour. Dear children, so if you want to convert meter per second to kilometer per hour, use this expression. 1 meter per second is equal to 18 by 5 kilometer per hour. So it can be 100 into 18 by 5 kilometer per hour. 5 ones are 5 20s are. So this is going to be 360 kilometer per hour. That's it. So you should have this clarity when to use this relation, when to use this relation. Dear children, this relation we have to use when you want to convert kilometer per hour to meter per second, whereas this expression you should use to convert from meter per second to kilometer per hour. Is it clear? Okay, just do it, copy it. Hey, don't forget that at the end of this class I'll give you few very sweet beautiful homework questions, so that you should solve and you should comment your answers. Okay, fine. Can I erase this? Now we discuss about uniform motion. We are going to discuss about uniform motion or uniform speed. Children, uniform motion, or you also can say uniform speed. So when you can say that body is in uniform motion, body has uniform motion. Look at here. So let me take my own example. It is A, it is B, it is C, it is D, it is E. Let us say some stops. The distance between A to B is, children, it is, let us say it's a 20 meters. B to C also 20 meters. C to D also 20 meters. And D to E also 20 meters. For suppose here one vehicle, car, my vehicle. Okay, yes. Let us say, dear children, this car to cover the A to B is taking a 5 seconds of time. To cover B to C also 5 seconds of time. To cover C to D also it is taking 5 seconds of time. To go to D to E also 5 seconds of time. So with this it is very clear that it is covering equal distances in an equal interval of timings. Yes or no? Yes. So now let us calculate the speed of vehicle in between A to B. So distance by time, that is 20 meter per 5 seconds. So this will be how much? 20 by 5, it is a 4 meter per second. And here also you can calculate 20 meter by 5 seconds. It is going to be a 4 meter per second. Here also you can calculate, it is 20 meters by 5 seconds. Children, it is also going to be 4 meter per second. Here also 4 meter per second. So just you can notice the body has the same speed, means speed is a constant. Speed is a constant. When the speed can be constant, children? When it covers equal distances in equal interval of time. Such a motion is called uniform motion. One of the best examples is that hands of the clock, dear children. Yes, it is in a uniform motion. Tick, 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 tick. So it covers equal distance in equal interval of timings. If any object or any vehicle is covering equal distances in equal interval of timings, then that particular body is said to be in uniform motion, or you can say the particular body is going with a uniform speed, because speed remains constant throughout the journey. Speed remains constant. Clear? Fine. Now we discuss a non-uniform speed. We discuss about non-uniform motion. Okay, non-uniform motion or non-uniform speed, anything is okay. Children, here I'll give a 3 examples so that you'll get a full clarity. Okay, fine. First example, 10 seconds. Dear children, look at here. Are you able to see? Let me check. Yes, you are able to see. That's fine. Okay, yes children. So if you can notice, dear children, here, so here in a uniform motion, body should cover equal distances in equal interval of time. Now let us notice this first example. In the first example, yes, let us say that body or ball or something, any object, okay, it is going, in all the cases same body, let us say that, or different bodies. So in first example, this body is covering 20 meters, 20 meters, 20 meters, 20, hey, same distance, but see the time. Here to cover 20 meters it is taking 10 seconds, 20 meters 7 seconds, 20 meters 11 seconds, 20 meters 72 seconds. So body is covering equal distances but unequal interval of timings. Equal distances, unequal interval of timings. Okay, fine. Second case, body is covering, let us say that A to B, 5 meters, 25, 11, 7, which means what? Unequal distances, but it is taking a same interval of time. So, in second case, body is covering unequal distances in a same interval of timings. But third case, if you can see children, distances are different, time taken are different. In these three cases, children, if I am not wrong, in a textbook, only they give one example. The first, based on this first only the definition is given. But in these three cases, body is said to be moving with a variable speed, non-uniform speed, or it is said to be in non-uniform, said to be has non-uniform motion. So, to say body is in non-uniform motion, three definitions are possible. First definition. So, if a body is covering equal distances in unequal interval of timings, or body is covering unequal distances in an equal interval of timings, or body is covering unequal distances in an unequal interval of timings, then also body is said to be having non-uniform motion. So, in day-to-day life this is possible. This is a very rare case it is. Special case only it is possible. Now you make it one doubt. Sir, then if the body is going with a non-uniform motion, then how can we talk about its speed? Oh, very good doubt you got it, children. I know that. So, if a body is going with a non-uniform speed, then we need to calculate the average speed. So, generally, will be what we can hear about the speed of a train. They will tell the particular speed will travel with this 80 km per hour speed. Whatever they are talking about 80 km per hour, it's average only. Hey, do you watch cricket match? They'll tell, what we can run rate per hour they'll tell. For example, if this is a run rate per hour is a 7, let us say that. Run rate is a 7. Does it mean that batsman is hitting every over 7 runs? No. In 1 hour, he may hit 1 run. In 1 hour, he may hit 12 runs. In 1 run, he may hit 20 runs. In 1 hour, he may hit, for example, 8 runs. So, average means they'll add all runs by number of overs. That is average actually. But if you want to know the speed of the vehicle whenever it is going with a non-uniform motion, dear children, we must calculate the average speed. So, now let us see what is average speed, how to calculate. So, children, average speed. So, average speed is nothing but a total distance traveled by total time taken. Dear children, in this first example, I will calculate. These two you should calculate. You must mention in a comment box so that I will understand whether my dear students are following my class or not. So that I will get a motivation and I'll try to make up rest of the chapters. I'll try to upload all rest of the chapters in our video so that very useful for your revisions to get the best marks. Okay, come on, let us have the josh. Don't leave that josh. Okay, come on children. So in the first case, average speed. So average speed I want to calculate. For the total distance, add the total distance 1, 2, 3, 4. So 20 plus 20 plus 20 plus 20. Okay, fine. Now total time 10 plus 7 plus 11 plus 72. Oh my god, it's going to be big. Okay, for example, let us say it is a 2 seconds only. Just for the sake of my understanding, I took it. Wait, 10. Okay, now look at it. So now the top one is 80 and this is going to be a 17, 19, 30. Correct? 0, 0. 8 by 3. So you divide 8 with 3 ma. 3 2 ja 6. It is a 2.66 meter per second. So this is the average speed. In between A to B, it may cover 20 meter per second. It is a 20 by 7 meter per second. But average speed we need to calculate. Whenever our bodies are going with a non-uniform motion, we must calculate the average speed. So how to calculate the average speed, dear children? Average speed is nothing but the total distance traveled by total time taken. Dear children, this first one I have solved, and the second one, in the second case, third case, what is the average speed? Just pause the video. So calculate the average speed in second case, calculate the average speed in third case, and comment your answer so that I will go through it. Okay, so children, this is about the speed and speed, uniform motion, non-uniform motion and average speed. Can I raise 3, 2, 1? Okay. Okay, children. Now we'll talk about the mass. Mass. Hey, mass means one Telugu movie is there. Okay, it's not that mass. Mass. Mama mass. Hey, mama. Bolkan song also will be there, right? Okay, fine. It's not that mass. Children, about this mass, already you had learnt in a class 6 also. Okay, so you can take every object, every particle must have some mass. The mass in the sense what, ma? The amount of matter. Okay, so what is mass, dear children? The amount of matter contained in a body. Amount of matter contained in a body is called mass. The children, then how can we measure the mass, ma? By using a physical balance. Using a beam balance also we can measure. Physical balance, beam balance we can measure. Okay, na? So, beam balance is used. Beam balance is used to measure the mass. And the specialty of the mass is that, dear children, for example, your mass is 50 kg. Whether you stand on Earth's surface or Moon surface, you will be in America, anywhere. Your mass remains constant. Mass does not change with the place, ma. Mass does not change with the place to place. Dear children, it's very, very, very important. In the entire universe, mass remains constant. Very important. So, it does not. It means what? Mass. It does not change. It does not change with place. It does not change with the place. Now, children, then in what units we measure the mass, dear children? Yes. So, SI units are kg, CGS units are gram. Dear children, you know the relation between these two? Let us see here. 1 kg is equal to 1000 grams, or 1 gram is equal to 1 by 1000 kg. 1 by 1000 kg. So, this is all about the mass. I repeat once again, look at here. What is mass? Amount of matter contained in a body is called mass. It is measured with a beam balance. It does not change with the place. Okay, it doesn't change even time also. So, and even if force also cannot change the mass. If force is acting on a body, its shape may change, volume may change, position may change, and direction may change, but not mass. Force cannot change the mass. Very important. And these are the units. Okay, fine. Now let us talk about the weight. Weight. In fact, you can learn mass versus weight. Mass versus weight. Dear children, mass cannot change. Mass can't be 0, but weight can be 0. When I say that, sir, how weight can be 0? Yes, because weight depends on gravity. Weight depends on the gravity. Okay, if gravity is more, weight will be more. If gravity is less, weight will be less. Gravity is 0, weight also 0. And gravity, especially changes from place to place, especially acceleration due to gravity, which you will be learning in higher classes, changes from place to place. As acceleration due to gravity is changing from place to place, and weight depends on acceleration due to gravity. Obviously, weight also changes. What actually the weight is, dear children? Weight is nothing but the force with which an object is attracted by the earth. If you can just throw any object upward, again it is coming back only. It is coming back only. Then you may get a one doubt, sir, then we are sending rocket, right? Why it is not coming back immediately? Dear children, their condition will be there. If you are sending any object, for example, if this what we can say marker is thrown vertically upwards with 11.2 kilometer per second, that is called escape velocity. If you can throw with that velocity any object, that will go out of the what we can say, range of the earth actually. It can escape, but generally we don't do with that much speed, right? That's why they are attracted by the earth only. Due to that earth pull only, every object has some weight. Okay, so weight is nothing but the force with which an object is pulled by the earth's gravity, you can say that, or a gravitational force, anything you can say, that is called actually weight. How can we measure the weight, dear children? Yes, weight is measured by using a spring balance. So spring balance is used to measure the weight, and the SI unit, see, weight is nothing but the force, right? So we can use Newton's unit. I am talking Newton, or CGS units are a dyne. CGS units are a dyne. So this relation is important. Of course, you may or may not have in your syllabus, but it's very important to have a knowledge always. Okay, 1 Newton is equal to 10 power 5 dynes. Dear children, other than this, we have a gravitational units. In a gravitational units we have kgf, also unit of weight, and gram force. Kgf means what? Kilogram force, gram force. Dear children, 1 kilogram force is equal to 9.8 newtons. Approximately we can take a 10 newtons. 1 gram force is equal to 980 dynes. And of course, can I erase this part? Mass 3, 2, 1. Okay, fine, dear children. Okay, so let me tell you here one important point. As I told you that weight can change from place to place. Dear children, this is a very, very important. Place to place. You may get one doubt, sir. If my weight is some x, if I go to the moon surface, how my weight will get affected? Yes, dear children, it will get affected. Remember that the weight of a person on moon is equal to the 1/6 of the weight of a person on earth. That's it. Very, 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 very simple. Very simple. Which means what? For example, when a person will go to the moon surface, his weight is reduced by 6 times. Reduced means won't get reduced. Feels due to the gravity, because their acceleration to gravity is less, right? 6 times it is less compared with earth. So obviously weight also will change. Here yours is 60. There moon means 60 by 6, 10. Here it is 100. On moon 100 by 6. Here it is 1000. On moon 1000 by 6. 1000 by 6. Okay. So here we have a small simple formula to calculate. W is equal to mg. Dear children, here mass is how much? Mass is, sorry, it is a m is a mass of an object. G is a acceleration due to gravity. On earth surface, this value is fixed, 9.8 meter per second square. Obviously we can take as a 10, sorry, no, what we can say, approximation we can take as a 10 meter per second square. For example, if you want to calculate a weight of, for example, a mass is equal to 50 kg. Then what is the weight? In exam they may ask a question, what is the weight? So W is equal to, we know this formula, right? M into G. M is equal to 50. G value is 10. This will be 500. Mass is kg. This is meter per second square. Simply you can write 500 newtons. This is how we can calculate. So this is story about the mass and weight. So with this I can say that we successfully completed the chapter 2 called motion. And you may get one doubt, sir, you promised that second chapter numericals will be uploaded. Sorry dear children, I forgot. Yes, but we do one thing in the next class. I mean, with today we have completed this chapter, right? So next, coming up to 2 classes. The first class we upload the numericals based on second chapter. In again next class we upload the questions related to the motion chapter also. Children, this is the second part of the chapter 2, that is the motion. First part is already uploaded. Link will be given in the description. Go through that video. Okay, children? Fine. And one more thing, children. It's very important. please read something, refer the textbook. Ultimately textbook see these videos or any material or chat GPT, Google, everything is okay, but ultimately you must read the textbook. And one more request, don't disappoint your parents. See, they are not asking you to get 100 and 100. First, see, they will respect the hard work what you are doing, but put your sincere efforts. We have seen some students, they'll come to the school, be doing a time pass, and their parents are thinking that my children are going to the school and they are doing the best. Please don't cheat your parents. That's very important. Ultimately, it's the parents, my dear. They are doing many things for us, right? What are we doing in return? Just studies, right? That was for our life, man. That is not for those. Okay, don't think that you will study so that they'll get benefited. It is wrong. If you study well, your life will be fine. Okay, na? So don't forget. So first, make a habit to respect your parents. It is not just saying good morning and good evening. If you are doing work sincerely, yes, which means you are respecting your parents a lot and you are loving your parents a lot. Okay, children, thank you so much. All the very best.